Playboy Cardi album tonight. That feels
Right.
good.
We are recording. Welcome to Thursday, April 23rd, H period Algebra 2. Okay. Let me go over a couple announcements as refreshers. Again, as part of this Zoom protocol and security deals. Whoops, why did I do that? Make sure you've got your video camera on. If it's not on, technically I'm supposed to
Put it on your face. Yeah, Cone, it has to be on your face.
Yeah, it can't be on your disco ball over the back of your head, whoever had the disco ball. I think it was
Sir.
Mr. Johnson, right? Yeah, he's got the disco ball.
Sir, those gluces look really good on you today. I don't know what you did. Did you shine them up?
What? Shine what up?
Your glasses? Like, I can see the reflection.
I turn the lights off in the room because it seems to make the whiteboard better.
Oh.
Some of you said that the problem set 5-23B wasn't attached to Blackboard. Is that right?
Yes, sir.
Yes, sir.
Okay. I will attach it after class, but give me about a half hour because I got to download this thing on YouTube. I'll attach it after class. I'm not sure what happened, but because about a half a dozen of you did put it in Blackboard. So how did you get it? You guys did put it in the Dropbox.
Sir, we just didn't get it. I looked on Blackboard last night and was not on there.
It wasn't on there.
It wasn't on Blackboard last night.
It might have been a technical error on my part. So I'll put it on there. We're actually going to go over. So does that mean you guys didn't do it at all?
No, we didn't have
we didn't have one problem besides the ones that we did in class the other day.
Okay.
Walter's burrito.
So I'm going to share my screen with you with that problem set because we're going to use that one to wrap up this section today. And I'm going to get you for the quiz, which is going to look
When's the quiz, sir?
not like this particular problem set. I will load it up after class today. Give me an hour or so. But
When's it due, sir?
some of you had problems getting a hold of 3B. A technical error on my part. I'm not sure. I can maybe figure it out when I scratch around on it. But look at that problem set first before you take the quiz, because that problem set was to prep you for the quiz.
Yes.
Once I load up the quiz, you will have, let's see, today's Thursday. It shouldn't take you but 20 minutes. All right. I would like you to have it done by tomorrow evening. Okay. You could hopefully you got 20 minutes over the next 24, 28 hours and knock it out then. Okay. All right. Also,
Clown.
listen closely. Some of you guys may be getting letters, interim letters. Some of you have quite a few zeros in there, and a couple things may be going on. I've got a stack I got a couple quizzes. I've got several problem sets, listen closely, that I've got over there that people did the work on, but they didn't put their name on it, and they don't have a distinguishing enough handwriting that I can say, oh, that's so-and-so's or that's so-and-so's. So you may have done the work, but you didn't get credit for it because there's no name on it. And once I download it and print it and maybe drop it out of either Dropbox or an email, I can't go back and try to match the email with the work. So go back behind me, all right, and look in Blackboard. And if you've got a zero on something that's sitting right there in your notebook, resend it to me via email. Resend it via email, not Dropbox, because I don't go back into, it's hard to go back into Dropboxes of 4, 5, 6 weeks ago. I'm teaching 6 classes now. I just picked up another one. So
That's such a fact, sir.
some students in each class has 6 or 8 Dropboxes. So I've got, even right now, I got 60, 70 Dropboxes. So it's a maintenance keeping nightmare. So just email me something that you did and you believe you submitted, but you still are showing a 0 for.
Yes. Yes. Who's Isabella James?
All right. And make sure, I stress that enough, that you put your name on anything you send me. Okay? All right.
Facts, Suki.
Any questions before we get going?
No, sir.
All right, let me
Let's get rolling, sir.
Let me do something here real quick.
Danish dumplings.
Portercock. Portercock here.
Porter code. Porter chode. Where are you?
Just remember, this is all recorded,
Oh.
and there's other folks looking at
Oh.
Yeah, Curse. Yeah.
No, sir.
this. There's other people looking at this. Supposed to not, camera's supposed to be on you.
Does that mean Curtis is getting a Boston?
Okay, so does this look familiar? This was the problem set that maybe some of you weren't able to get a hold of.
Yeah. Yeah, that was on. That was on our.
Now we did several of these in class the other day, right?
Yes, sir. We did like 1, 3, and 10 or something like that. I don't have my sheet in front of me.
Yeah, I think we did one. Didn't we do this one? Had all the, because we're missing an a squared and a. Didn't we do that one?
Yeah, I think so.
Okay. All right. So did most of you not do this problem set before? I'm trying to figure out
No.
the way is to, no?
No, like I physically couldn't see one other problem besides like when you pulled it up in class.
Okay. Let me do this then. Because I only want to spend about half the class on this. Let's, all right, let's take a look at 5, 6, 7, and 8. All right. Which of those problems, let's do number 8. Or let's do number 7. Write that problem on a sheet of paper, okay? Write that problem on a sheet of paper. I'll walk you through that number 7, okay? I'm gonna stop there. Let's see,
Which one do we write down?
Number 7.
It's 3w cubed plus 7w squared minus 4w plus 3. Actually,
That
let me see if I can do it on here. The writing's going to be terrible. All right, let's see if we can.
No.
Let's see if we can do this synthetically, okay? So we're going to take the divisor and we're going to change the value of, we're going to change the sign of the divisor to 3, all right? Then we pick the coefficients right off the variable, so we got 3.
Wait, sir, is that -3?
No, it's positive. Yes, -3 is our divisor because remember we changed the sign.
Oh, yeah, that's right.
We
That's
got
right.
a 7, we got 3, 2, we got a -4. And I'm sorry, it just makes it real hard to write. And this is a 3. So I just bring the coefficients down. We draw a line, leaving room to work. 3 comes down as written, right? So that comes down as written. Now we multiplied -3 times 3.
It's -9.
Thank you, -9. All right, and now we add this, which is different from long division, right? So this becomes -2. 7 plus a -9 is -2. Now we multiply -3 times -2. That becomes +6, right?
Which means +2.
Toward +6, we got a +2. Now we multiply -3 times 2. And we've got a -6, right?
Yeah.
And then we have -3. All right, so what we just did, we divided that polynomial by 3, but we haven't addressed the w. So how do we address the w? We just,
Distribute.
w divided by w is w squared. So now we're just going to, all we got to do is put w squared here.
I can't see anything.
You see it? The w
Yeah.
is here, it goes down in sequential order. That's minus, that's a +2 here, which you don't have. Sorry for that messy handwriting. I'm trying to do it off the problem set as opposed to on the board.
It's okay, Suki. I still love you.
-3, and that's a remainder, so that goes over w plus 3. You don't have 2 constants. You're only going to have 1 constant, and if there's still another value, that is the remainder.
Wait, so it's -3 over w plus 3?
Correct. This part right here is your remainder.
Bet.
Any questions on that? Now,
No.
let's briefly look at this one here. All right, because this is one that could bite you. All right, so we got -1, but look what we got. You've got to account whether you're doing long division or synthetic division for every sequential exponent starting with whatever the largest one is. So we start with 3m to the 5th. So the 3 comes down, right?
Yes.
Yeah, but we don't have an m to the 4th. So I need a placeholder. I'm just going to use 0, even though it looks like
The heart.
0. All right, I don't have a m to the 3rd. So I do that same thing again. I don't have an m squared, so I do that again. I've got an m to the 1st, so I've got a +1, and then I got a -1 constant. Make sense so far?
Yes.
We draw our line. The 3 comes down just as written. -1 times 3 is a -3. -1 times -3 is a +3. -1 times 3 becomes -3. Kind of a pattern developing here, right? Let's see, wait a minute. Whoa. Let's see, we're subtracting here. 3 minus 0, okay. 0 minus a -3 is a +3. So now we've got 0 minus a -3 is,
It's +3.
oh, did I tell you something wrong? Yes. Because in synthetic division we add. So this
So -3.
3, -1 times 3, this becomes a +3. Sorry for the confusion. Just remember, with synthetic we add, with long division we subtract. So we back up to speed, and then we go -1 times 3. Let's see. Oh, I'm sorry. 0 plus 3 is 3. My brain's
Yeah.
on two different sequences of what I'm saying and what I'm doing. All right. So 0 plus 3 is 3. Now we got -1 times 3 is a -3. Right? 0 plus -3 is a -3. Sorry for the messy handwriting. Looks like some of your alls. So now you know how I feel. -1 times negative.
Appreciate it, sir.
Okay, thank you. -1 times -3 is a +3, isn't it? Is that right? Yeah, +3. Right? And then we add that, and that becomes. Oh, this goes here. It's hard to do with this stylus on this thing. So that's a +3, right? So 1 plus 3 is 4. -1 times 4 is -4 here. I try to erase this, but this is actually a -4. Everybody clear there? Negative.
So it's not a +4?
It's a -4, right? Because -1 times 4 is a -4.
Oh, yeah.
Let me do something. Let me do versus that.
Welcome down.
Let me clean up this mess.
Walk down.
Sorry about that. Oops. This thing is so
That's cool.
So that's -4. -1 plus -4 is a -5. I know this is really scratchy writing.
It's all good.
So now we got to go back and slap the m's and the exponents on it. So we're dividing everything by m to the 5th by m. So we start off with m to the 4th, and we're going to go right down in sequential order. And I'm just going to, let me just come down here where I got room. So that's 3m to the 4th minus what? 3, boy, this is really scratchy. 3m cubed plus 3m squared, right?
Yeah.
You're doing good. Sorry for the messy handwriting.
And then plus.
And then it's minus 3m. I'm going to come down below it. Let me know if this doesn't make sense.
Wait. Oh, wait, never mind.
Plus 4.
Yeah.
Oh boy, I slipped up there. Minus, that's a remainder, minus 5 over.
Over m plus 1.
Exactly, m plus 1. And I'm trying to get a pad that has a stylus so I can do this with a little better writing. So I know that's messy. Anybody have any questions on that?
No, I understand it now. That's kind of easy. But
Okay.
so, like if you so like how there's zeros,
Yes.
if you don't have like a number like why would you choose 0?
Just because it doesn't have, you know, it doesn't have a numerical value, so to speak.
Okay.
We started off with m to the 5th, and part of this, whether you're using synthetic division or long division, these exponents have to go down in sequential order with no skips. And we went from m to the 5th to m to the 1st. So that's why we used 0 to the 4th, 3rd, and 2nd, because those exponents are skipped. And that's the only way you can do this using either the synthetic or the long.
Yeah.
Other questions on either of those two?
Very easy.
Let's see here. Let me do something here. I'll try to. All right. Okay. Let me ask you a couple of questions. What are you being asked to do with this particular problem?
Distribute the -1 to each.
Is that correct? Anybody else have any thoughts on that?
Don't you just, you're flipping the signs of like X and 2?
Yeah, because you're just distributing.
You're just distributing that.
Let me back up here 1 second.
Like it'd be -x minus 2.
Yeah, let me hold on 1 second. I got a technical issue going on. Let's see.
Come on, Suki, we can't have that.
Okay, sorry about that. What? If we didn't have some technical glitches, it wouldn't be algebra, right? All right.
Yes.
Remember, we've got a negative exponent of that. What's it? This is really this. You take the inverse, right? So really that's just, it's kind of, it's not a trick, but this is really what it is, right? So it's really, this is just another way to express that you're dividing this polynomial by this binomial. You're not multiplying because remember, you're never going to give me an answer or a PSAT or SAT test answer with a negative exponent. You're always going to simplify or amend the problem or alter the problem so that you will not end up with any negative exponents. Okay? So is everybody clear on that? This is just, all you're doing is you're dividing this thing by x plus 2. Do we all agree on that?
Yes.
Make sure you know that's all it's asking you to do. It's just a different way of expressing it. Are we good? If you want to write that problem down, yeah, let's see here. We did that.
So if you, oh wait, what if you had like a -2 instead of a -1?
-2. They won't give you that because that's not a long division or synthetic division problem.
Oh, okay.
Okay. Do I need to work this one out? I'm going to do it on the whiteboard because I can do it quicker and neater. If you want to do that, we can do that on the whiteboard. So keep that. Just let me know here in a couple minutes. I want to talk about. Let's see. I want to talk about these bottom 4 or 5 problems. All of these, that's why I told you, I'm not going to be that obvious on the quiz, have to be done with long division because the binomial, the x has a coefficient other than 1. So you're going to have to use long division. You may see one of these on the quiz. This one has a coefficient of 1, but this is somewhat related to Mr. Carpin's question. This has an h squared as opposed to the first power. So that too has to be done by the long division. Synthetic won't work on it. And I'm going to do this one. I'm going to do this one on the whiteboard here in just a minute. If you want to jot any of these down, if you couldn't print that out, I'll leave this on here for a minute or two. And if you want me to work, I think I worked number 10 in class on Tuesday. I'm pretty sure. Right?
Yeah.
And then this one down below, this word problem, all you do is you divide this polynomial by this binomial, all right? And again, because the binomial has a coefficient other than 1, you're going to have to do long division. I'll just kind of give you the answer on that if you've got the problem set there, or you want the answer to work towards.
Sure.
It's x minus 3 feet. Go to the question.
Wait, so for 10, 11, and 13, why are there zeros circled?
Oh, because I slid the screen down, so that doesn't.
Okay.
That doesn't make any sense now.
Right.
Yeah. All right, I'm going to do number 13. I'm going to turn the stop share screen off. Let's see here. Give me 1 second. Let me just change the view, speaker view. That's not how I wanted it. Let me, okay. Okay. I told you I would work this one with the h squared. I think it's number, you jotted it down. Let's see, it's number 13. And actually, I messed up that you guys didn't get the problem set, and that was probably my fault. Let me come back over here. All right. If you want to jot these answers down, I'm just going to let the screen sit here for 90 seconds. This is the answer key. All right. Well, there's the odds 1, 3, 5, 7, 9. There's the evens 2, 4, 6, 8. Okay. So I'm just going to let it sit there for a second and give you a chance. I would encourage you to write those answers down. I will go back into that assignment from Tuesday, and I'll fix whatever the problem was, why some of you couldn't access the problem set. But again, it'll be an hour or two before I get to it this afternoon. So if you want to jot these down, and then take those problems and try to make sure you obtain these answers, you can do that. So just take a look at that for a second. Jot any of those. Again, that's the answer key. Jot them down. Everybody see them okay? I'll give you a second, and then I'm going to move over and do a couple things on that side too of the problem set.
Are we only doing the? Oh wait, never mind.
I'm sorry, these guys are right outside the door here, or window here, working. Say the question again. Okay. Yes, Mr. Cohn. You know, when whoever's making the most noise pops up on my screen, so it's not like a mystery. Probably shouldn't have told you that. Okay, does anybody need any more for these? All right. Let me come down here. All right,
Hey, Eddie.
Here's the answer key for side 2 for 10, 11. These were the long division, ones that you had to do long division. All right, I'll give you a second to jot those down. Those of you that would like them, I'd encourage you to do that, particularly if you didn't do the problem set, so that you can get practice on a couple of these before you take the quiz, and it'll get you better prepped. And then I'm going to work number 13. It has the h squared. All right. Everybody ready? Here we go. So this is action number 13. It's 2h to the 4th. Make sure I copied it down. Minus h cubed plus h squared plus h minus 3. The first thing you want to do is make sure every exponent is accounted for in sequential order. 4, 3, 2, 1, none. Perfect. I don't need to have any fillers or spacers. All right. So remember, we're going to work from left to right, and we want each one of these things to zero out. So we get all the way over the right side. So the first thing I'm going to focus on is how many h squareds are in 2h to the fourth, all right? So we know it's 2, right? 2, and then h to the fourth over h squared, thinking back to problem section 5-1, equals h squared, right? Because 4 minus 2 is 2. We subtract exponents of like bases to solve the division problem. So I know it's 2h squared. So watch carefully. It's 2h, it's this 2 plus the h squared. Now we put that, remember, think in terms vertically. We put identical bases and identical exponents over each other. So this goes way over here. Not here like it normally does, but way over here. So the h squareds are over the h squareds, right? Let's see here. Yeah, so now I go 2h squared times h squared is 2h to the fourth, which I already knew is what I wanted, right? And then I got 2h squared times -1 is a negative 2h squared, right? So this zeroes out. The negative h cubed comes down because I don't have anything here to add or subtract it from. Actually, we're subtracting, right? And then I got h squared minus a negative 2h squared, so that's plus 3h squared. Are we good? So now I'm going to look at, I want this h cubed to cancel out, so I want to know how many h squares are in negative h cubed. Well, 3 minus 2 is 1, so it's a single negative h. So that goes right here. All right? So negative h times h squared is a negative h cubed, which is what I set it up to do anyway. And I got a negative h times a -1, which is a negative h. This one kind of gets a little messy because you got some gaps in here. So that zeroes out. I got 3h squared minus nothing, so the 3h squared comes down. And I got h minus h, so that's a big zero there, right? Oops, wait, I'm sorry. It's h minus a negative h, so it's a plus h. So that is plus 2h. Sorry about that. All right, so now I want to know how many 3h squareds, how many h squared are in 3h squared. So that zeroes out, so it's 3. So I put a plus 3 here. So 3 times h squared, which we already know because we set it up to do that, is a 3h squared. And 3 times -1 is a -3, all right? So 3h squared minus 3h, that zeroes out. The 2h comes down. And let's see here. Where was I? Oh, I got a -3 here, right? So I got a -3 minus a -3, so that cancels out, right? I got this -3 minus a -3, which is the same as +3. Am I getting out of the way? Yeah, come over a little. Sorry about that. Let me come over a little bit. So that cancels out. -3 plus or minus a -3 cancels out. So I got 2h left. All right. So my final answer, I forgot to put the remainder on it, is 2h squared minus h plus 3. And then I've got a 2h. Is that right? Where'd that come from? Yeah, I guess that's my remainder. 2h over the divisor of h squared minus 1. All right. Questions on that? Everybody see that? Everybody's still out there, right? Pretty quiet?
Yes, sir.
All right. Let's take. Did I leave anything out? Did I leave anything out? I'm just checking in.
I'm so serious. It's not the fucking drop.
You all right, Mr. Neighbors?
Whoa, neighbors, what are you
Yeah.
watching?
What was that?
Okay.
Neighbors,
So-
what you watching?
Is Isabel yelling at you, Nick?
All right. Let me do a quick let me do a quick share screen.
Leave Olivia alone.
Okay, anything else on this problem set I need to clear up? This is the last problem set on 5-2. Just remember that if the divisor, the binomial has the variable has a coefficient of the 1, you're going to have to use long. And I'll try not to do but 1 or 2 of those, so the rest you'll have the option of using either long or synthetic. Choose the one that you've practiced the most and that you're the most proficient in, okay? I apologize if it was my part that messed up not attaching this correctly to the Blackboard entry from Tuesday. Like I said, I'll fix that after I get out of class here, probably be about an hour or so. I would encourage you, if you weren't able to obtain the problem set, I wish some of you guys would have come online during office hours yesterday and told me that. But anyway, I will attach that. Go back and hopefully you copied the answer key down off the board and do a few of these before you take the quiz. I'll load up the quiz this afternoon. I'd like for you to take it by 8 or 9 p.m. tomorrow night. So the quiz shouldn't take you but 20 minutes. So just dedicate 20 minutes at least to Algebra 2 between now and tomorrow evening. Any confusion or anything else I can clear up on this before we jump into the next thing?
When did you say the quiz was due, sir?
Let's do it by 9 p.m. tomorrow night. That'll give me the weekend to grade because I need the weekend to grade stuff because it's hard to do lesson plans during the week.
Yes, sir. Just writing that down.
I'm trying to think of what else do I need to say. Oh, be careful or make sure you put your name on your quiz. Because I still have quizzes over there with no names on it that people have zeros that submitted the quiz. So it behooves you to get on Blackboard and check your Blackboard, like, why do I have a 0 on this quiz? I did it. If that's the case for you, just resubmit your quiz via email, not via Dropbox. I will not penalize you if it's one of the same 3 or 4 quizzes I still have sitting over there with no name on it. Any questions? Before we change tactics. Okay, we got what, 15, 20 minutes left? All right, I'm gonna stop share there. Give me, I'm gonna pull something up. It's this one. Yes, excellent. All right. Where'd I lose you guys at? Okay. Shoot. Give me. All right. Now I'm going to share screen again. Let's see. I don't want that one. Okay. Here we go. Let me enlarge this a little bit. Everybody still with me? How come you guys are so quiet?
Tired, sir. Been a long day.
Long day. Okay. All right. So now talking with the Ms. Dolmage, who's going out on maternity leave here in a day or two, and to get you guys prepped as best we can, particularly you guys that are going to move on to pre-cal or calculus. I'm cherry picking some sections here these last 3 or 4 weeks of school to get you better or best prepared for that. All right. One of the things we're going to move on to section 6.4 with roots. And you're already somewhat familiar with them. It's just a slightly different way of looking at them. And this problem set, I did a little bit of research and I definitely tried to beef up the narrative here and the notes on here so that they're more valuable to you. And it's not really new information. It's just kind of looking at it from a different angle or perspective. And there's actually 6 properties here. There's one, there's one here, 2 or 1 here, and then you got 4 here. So there's 6 properties that we're going to apply. Most of these you've already experienced and utilized and been familiar with, but I'm going to do kind of a brief recap on these. So I'm going to go through them fairly quickly unless you stop me and have a question. It says for any real numbers A and B, if A squared equals B, then A is the square root of B. And when I read these things, it's like talking to a lawyer or something. It sounds like a lot of mumbo jumbo. So I like to put it into real terms. So what this is saying as a real life example says if 2 squared equals 4, then 2 equals the square root of 4. And think of it in terms of if you're a Wizard of the Oz fan, when you're looking at the Dorothy's talking to the scarecrow and they say, which way do they go? And he's going doing this. It's kind of like this. We're going both directions. 2 squared equals 4, 2 equals the square root of 4. Likewise, another example would be if I had 3 squared, that equals 9, right? This will be on your problem set. And then another way of putting that is then 3 equals square root of 9, right? Or 9 under the radical. If there is nothing here in this part of the radical, it's always square root. If it's something under the square root, that'll be there. And we'll talk about that here a little bit further down the line. All right, so that's square root property. The next one is the nth root property. So for any real numbers A and B, any positive integer, A to the n equals B. Again, it sounds like a bunch of mumbo jumbo, but here's real life application. It says, and it's kind of similar to what we had here. It's kind of very similar to the previous one. Again, it's roots versus squares, right? Radicals versus squares or cubes or to the 4th powers. Roots versus exponents. So 3 squared equals 9. 3 is the square root of 9. And likewise, 3 cubed equals 27. And 3 is the cube root of 27. Is what all this kind of mumbo jumbo says, right? And you already kind of knew that. You've already used it. You've applied it. It's just, these are the properties and tools that allow you to do some of the simplification that we're going to do in this particular section. All right, these next 4, I think it's actually easier to start from the bottom. All right, so let's do this. If n is odd, okay, which means odd is 1, 3, 5, 7, 9, 11, and so on, right? So n is the root, all right? And b is less than 0. What that's saying is b is a negative number, which is really what it makes more sense to say. Just b is a negative number, so b is less than 0. It's kind of like we're making it more complicated than what it has to be. But all that means is b is a negative number, what I circled there, all right? B has 1 negative real root, all right? So negative 27, the cube root of negative 27 is negative 3. Well, why does that work? Because negative 3 times negative 3 is a positive 9. That's square root. And then I got to multiply that positive 9 times that 3rd root, that negative 3. That brings me back to a negative value, and it's negative 27. Does that make sense? I know I'm kind of going fast here. All right. So let's look at the next one. So in this case, the root is even. 2, 4, 6, 8, 10, 12. You already knew that. B less than 0. We're still talking negative numbers. All right. This means no real roots. Well, what do I say? I'm just going to say no solution. Again, let's just keep it as simple as we possibly can. So the square root of negative 4 is no solution unless we kind of, and we're going to throw out what we learned 6 or 8 weeks ago. Remember with the imaginary numbers and the i's and the complex numbers? We're not looking at that for this particular section. There is no solution to that. There's no 2 numbers, identical numbers, that I can multiply and get a negative value. There's no way of multiplying and getting a negative value is one of the numbers has to be positive and one has to be negative. And that's never going to occur when I've got even roots to the 2nd power, to the 4th power, 6th power, 8th power. Does that make sense? Any questions? All right, hearing none. Okay, so these upper 2, all we're saying is b is a positive number as opposed to 3 and 4 where b is a negative number. Again, if they just say b is positive, b is negative, it's easier than this way of presenting it, but that's just me personally, all right? So n is odd. So there we're talking about, once again, 3, 5, 7, 9. So the cube root of 8 is 2. So there's 1 positive real answer, all right? Just like down here, there was 1 negative real answer or real root. And just like in number 3, there was no way, ain't gonna happen, no possibility. So the cube root of 8 equals 2 is what that's saying. Let's see, what else can I say about that? Let me see. That's it. Now, once again, now n is even, 2, 4, 6, 8, 10, 12. B is greater than 0. All right. The answers now, you've got one positive real root and one negative real root. And I changed the wording, and I should have changed the wording on this garbage here, but I didn't think of it until I realized how poorly that sounds. So what that's saying, the square root of 16 can be a -4 or a +4, all right? -4 or +4. Because -4 squared is 16, +4 squared is 16. So don't get hung up on the verbiage. I think the examples are a little more cost effective, so to speak, because the verbiage, I think, kind of muddies the water. And you've used, I think, probably all 6 of these to some degree or another. And I just want you to know, these are the tools and properties that allow us to do what we're going to do for this section. We're going to throw all that imaginary number stuff, complex numbers out the window for this section. No eyes. The eyes don't have it here. All right, so let's look. This will be in Blackboard in an hour or two. All right, let's look at the examples are good. All right, so this problem here. There's nothing right here in the radical, tucked in that little corner of the radical, so it's a square root. So the square root of 49 is 7. Right, that's where that comes from, right? All right, and z to the 8th, I want to pull out all or as much as I can out from under the radical as z to the 8th. All right, so what times itself is a square root of that? So if I just think kind of logically and mathematically, z to the 4th times z to the 4th gives me z to the 8th, right? Because I got identical bases. I actually have identical exponents. When I multiply identical bases, I just add the exponents, right? So another way you could write this z to the 8th, that is the same as z to the 4th squared, right? So it would come out from under the radical just as z to the 4th. So there's the answer, even though I scribbled all over it. It's 7 z to the 4th. Is that logical based on what we did in 5.1 and what I just talked about? Everybody's quiet. Okay. Let's look at this guy. All right, so now we've got a 3 here. So we're not taking square roots, we're taking cube roots, all right? So they kind of did what I did over here with z to the 4th, instead of rewriting it. They just broke this up, because remember, when our exponents have exponents, instead of adding the exponents like we had 4 plus 4 is 8, we multiply them. 2 times 3, 2 times 3 is 6, right? So really, this is 2a minus 1 squared, then to the 3rd power. So this whole thing would come out from under the radical just as written there, instead of me writing it real scribbly. So 2a minus 1 to the 2nd power is the answer for that. So this will all be on your problem set. Like I said, I tried to kind of beef up the kind of the preliminary information in this section, just because we don't have as much interaction with you guys being at home and not being in the classroom. Okay, give me 1 second. Any questions? I'm going to walk you through a couple of these. This is the exact problem set. Give me a second. All right, I'm going to walk you through a couple of these. And again, we did a lot of this in 5-1, and we've done some exponents and radicals earlier. So it's not super new. All right, let's change things up. So anybody, all we're doing here, there's nothing right here, right? So it's a square root. So what's the square root of 81? You've got that little handy dandy, hopefully that little,
9, sir.
9. So that's it. We're done with that guy. All right, this guy here. All right, we can actually solve this. Why? Because looking at that sheet above, it's a cube root, and I've got a negative under the radical. And remember, I can get a valid answer without using that imaginary complex stuff, which we ain't going to do in this section, because a negative times a negative squared, that's going to be a positive. And then that 3rd to the 3rd power times a negative again is going to give you back to a negative answer. So I want the cubed root of negative 343. I know it's going to be a negative response. And if you can actually put this in your TI or whatever calculator you're using, and I'm just going to get ahead of you. It's a -7. So -7 cubed, -7 squared is 49. 49 times -7 is -343. And I'm going to do one more, and I think we're going to be out of time. All right, so again, nothing right here, so we know what's the square root. You've got your little handy-dandy cheat sheet. So the 144, square root of 144 is 12, or 12 squared equals 144 if you want to use that property 1 and 2 up above, right? P to the 6th, all right, is the same as P cubed times P cubed, right? Or P to the 3rd squared again, right? So that's perfect. I can bring that thing out as P cubed. All right, so that kind of gets you in the flow or groove of solving this, all right? So I'll have 2 entries today. One will be the quiz assignment, which will be the 5-2 quiz. Make sure you do that by tomorrow night. Make sure you put your name on it. I apologize if I messed up on that 3B problem set, but I will load that up to the day. So you actually have 3, well, now I'm just going to put it on the entry from Tuesday. I'm not sure why that got messed up. So make sure if you don't feel real confident on the 5-2 on the dividing polynomials, do that 3B, practice a few of those before you take the quiz. Make sure you put your name on it and then drop it in Dropbox before 9 o'clock or so tomorrow night. And then I will also load this up. This takes back seat to the quiz, and then work on that. Just drop it in the Dropbox before Monday night so I can take a look at how you're doing with this before we're back together again on class on Tuesday. I know I went kind of fast, but it wasn't as productive as normally are just because of the issues with problem set 3B. Any questions or comments?
No, sir.
Okay, looks like Mr. Neighbors is getting ready. It's about close to nap time.
So I'm getting there.
Sir, it's nap time.
If you want the extra 10 points for on office hours, 2 to 2:30 Monday through Thursday, 9 to 10 on Friday. If you run any problems with the problem sets or the quiz between now and tomorrow morning, I've got office hours tomorrow night or tomorrow morning, 9 to 10. So it'll be another chance to catch up with me.
Love you, sir.
Also, you guys that go back and check behind me with Blackbaud, you may be some of the guys that didn't put your names on either a quiz or a problem set that you actually did that I can't put a grade to in your grade book because there's no name and I don't recognize the handwriting. So that's actually in your court. I don't have any other, I can't just arbitrarily assign names to quizzes with no names on it.
Yes, sir.
Okay? That's your responsibility. Take a few minutes to make sure you have been fairly and accurately treated on Blackbaud. All right?
Love you, sir.
Have a good weekend. Stay safe.
See you later, Hank. Love you.
We'll see
Love you,
you
too.
Tuesday afternoon.
See you later, sir.
All righty, we'll see you.